we need to solve it on the board. Somehow I will solve it on the board only. Okay. So, okay, good morning, all of you. So today we will see iteration bound. We have just discussed last time about what is the iteration bound. Okay. So just to introduce what is the iteration bound, that I will just quickly go through some PPT and then we will solve the example. Okay. Regarding how we can find out the iteration bound. So when I talk about any DSP algorithm, the DSP algorithm are recursive in nature. Maybe they are having some sort of feedback loop which actually restrict their sample period. That means what should be a time which I can assign to that particular DSP system. So that lower bound which is applicable for any DSP algorithm, that we define as a iteration bound. Okay, it is iterative in nature, continuously running. Now, when we want to find out the iteration bound, then there are few methods to do it. One of the method is to find out the loop bound. So sometimes this method loop bound would work, but sometimes it may not work. Okay, we will see that what is the limitation of that and why we want actually some sort of algorithmic approach. So apart from that, there are two algorithmic approach which we can apply, is a LPM, longest path method, and another is a MCM, minimum cycle mean. Now clock period is always defined for any system through a critical path that we have seen. Okay, means when we talk about retiming, at that time we have seen this, that ultimately if I want to find out a system, a performance that maybe gives you the clock frequency. So for that you need to actually find out the critical path. Okay, now sampling rate throughput, that means the number of samples or number of output which is being generated per second. Okay, so this concept probably we will discuss it more clearly when we talk the next topic, which is a pipelining and parallel processing. But consider right now that throughput is a output, number of output which is generated per second. Now when we talk about the iteration bound, then iteration bound will let you know that what could be the minimum period that I can assign to recursive algorithm. Now this will let you know that how the system performance can be improved. Now if I want to consider a one particular filter, let's say that I am talking about one IR filter. Okay, so for a IR filter, the equation is yn is equal to AYN minus 1 plus xn. So this is just an equation that we are talking about. Now if I want to just draw a graph which represent this mathematical model, then this would be the part A. Okay, so ultimately if you observe that in this equation, what are the two operations I require? This one adder, of course I require, and A into yn minus 1. So that is the multiplier. So adder and multiplier I require. So that I observed the two node. So that is two functions are nothing but equal to two particular node. So this is my DSP algorithm. For that the DFG is being drawn like this. So you just observe that I am providing xn, it is generating a yn. Now yn will multiply by a. So output of this multiplier is y a into yn, and through d I am generating yn minus 1. So this yn minus 1 here, a into yn minus 1 will be added with the xn and it will generate to yn. Okay, now over here if you observe that there are two nodes and there are two edges which shows the relation among the two nodes. So one edge is which goes from adder to multiplier. Okay, where the yn is being defined. Another edge is which goes from multiplier to adder. Now, if I observe that from adder to multiplier, which is the top edge, okay, so over there is no delay element. And when I observe the below edge, which goes from multiplier to adder, it has a one delay element. So when a particular edge has zero delay, then I can define that intra iteration period. Okay, so for that edge, whatever the time that I can observe, that is the intra iteration period. So when for a edge there is no delay element, then I can consider it is an intra iteration period. Okay, so that in another way you can say that that is a critical part, that what we discuss in a retiming. And when we talk about a edge where you have a delay element, maybe one delay element or more than one delay element, then ultimately that particular thing that you can define as an intra iteration period. Okay, so inter iteration period. Okay, so inter iteration period is having a, or for a edge, that particular edge you have having a one particular at least one delay element. Okay, so this is just pictorial representation. Now talk about the iteration bound, how we can find out the iteration bound. Okay, so for that just you need to understand that, before that you need to understand some terminology. So let's talk about it. So first is the critical part. Critical part, we know that the longest part among all the part where there is a no delay element, that we have seen that. Loop. So loop also we know that from the point when it starts and again come back to the same point, then we consider as a loop. Loop bound. So loop bound is basically defined as a TL by WL. TL, that means total delay of a loop divided by number of delay element. Okay, so that we will see with the example also. Critical loop, the loop which has a maximum loop bound, that we consider as a critical loop. And iteration bound is nothing but whatever the loop bound that you observe, from the loop bound, whatever the maximum value that is being calculated, that we consider as a iteration bound. Now let's consider one particular example which is actually drawn on the means this particular graph. Now let's try to find out the iteration bound of this particular graph. Okay, now for this particular graph, if I observe that 1 2 3 1 2 3 having a execution time delay 1 and 4 5 6 having a delay 2. So that I am just writing. Okay, now try to solve this. So here the delay which is being defined as a 1 and here it is 2. Now we need to find out the iteration bound for this particular graph. So iteration bound is maximum of loop bound. So that means if I want to find out the iteration bound, then I need to actually first find out the loop bound. And from a loop bound, whatever the maximum value that I can assign to a iteration bound. Now, if I want to find out the iteration bound, then first of all, calculate the loop bound. Now for loop bound, you need to first observe the number of loop in a graph. So for this particular graph, I believe the direction is being defined. Okay, now for this, if I consider, then how many loop you have? You need to first identify the loop. How many loop you have? How many loop you have? Yes. This is not
Six.
a
6.
6 loop. Okay. Let me know what are those. See over here, this is the way it is going. Okay. Okay. So again I am asking how many loop you have? How many loop you have? Okay. Try to find out one by one. First, what is the first loop? Let's consider I am starting from this point. Okay. So what is the first loop? 1, then D1, sorry, D2, D3, D4. I forgot just one notation. Sorry, this is D4. D1, D2, D3, D4. So 1 to D1, 2 D2, 4 2 1. This is my loop 1. I am starting with 1 D1, D2, 4 2 1. L2. Second loop. So second loop will be 1 2 D1, D2, D3, 5 3 2 1. Okay. Third one. I am starting with 1 D1, D2, D3, D4, D6, then 3 2 again 1. Yes, am I right? For this particular graph there are 3 loops. Okay. Any other loops? L4, somebody mentioned 6. Okay. So there has to be L4, L5, L6. What is L4, L5, L6? So there is no more loop in this particular graph. Is this clear? For this particular DFG, is there any fourth loop? If it is, then you need to actually observe. If you fail to do it, it may happen that generate the largest delay, and that could be your iteration bound. So you need to identify the loop closely in this particular graph. So I believe that these 3 loops are good enough. Okay. Now I need to find out the loop bound. So loop bound, I need to find it out. So loop bound L1. So loop bound L1 is a total delay in the loop divided by number of delay element. ठीक है. So for L1, what is the total delay? So delay means execution delay. Execution delay will be applicable to my node. Okay. So if I consider the total delay in loop L1, what is the delay? 1 to 1. So that is 1 to 1. Divided by number of delay element. How many delay element you have? For this particular L1 loop, how many delay element you have?
2.
2. So it is 4 by 2. So my L1 is 2. Similarly, I need to find out L2. What is L2? Again, number of delay or total delay in a loop divided by number of delay element. So for L2, what will be the case? For L2, total
5 by
delay.
3.
It is 5 by 3. Very good. L3. Again, for L3, total delay of that particular loop divided by number of delay element. So it is
5 by 4.
5 by 4. Now my iteration bound. What is iteration bound? It is a maximum of loop bound. So I have a total 3 loop, and for each loop you need to find out loop bound. So that means 3 loop I have. For each loop I have found a loop bound. So that means it is maximum of 2, 5 by 3 and 5 by 4. Iteration bound is the maximum of loop bound. So loop bound L1 is 2, loop bound L2 is 5 by 3, and loop bound L3 is 5 by 4. So that is, so iteration bound of this particular graph is 2. Yes? Okay. So it's very simple. You need to just observe the loop. From the loop, you need to find out the loop bound. And once you found out all the loop bound, then you need to find out the maximum of all of them. And that is your iteration bound. Okay. So this is a good method. Okay. But there are some issue with this method. Okay. First thing is, this particular method depends upon number of loop that you observe inside this particular graph. Okay. So now, while we are observing a loop in a particular graph, then it is just our human observation, and through which we are finding the loop. So initially only that there are various answers. Somebody says 3, somebody says 6. Okay. So now, if still for a DSP circuit, this could be a very simple one. You can have some sort of complex DSP algorithm where the graph will looks like a very different one. Okay, where through a human observation, it is very difficult to find out the loop, because this method totally depends upon how you observe the loop. Once you identify the loop, then you can find out the loop bound. See, to calculate the loop bound, it is not a bigger issue, because once you identify the loop, you can find out the total number of delay through observing the node, and then total number of delay element. So that's okay. But to identify the loop itself is a challenge, because that totally depends upon how you observe the DFT. Now, so that's why people have come up with a different algorithmic method. Okay, so when I say algorithmic method, then algorithmic method is having some finite number of steps. And if you follow those steps, then definitely you will get to, or you will get the correct value of the iteration bound, irrespective of the complexity of your graph. Of course, the complexity of graph is determined. Okay, but if algorithm is known to you, then what is the good thing that you can do? You can write down the code just to follow that particular steps, and then automatically the iteration bound would be calculated. Now, for this method, if I ask you to write down the code, it would be difficult. Okay, You cannot write down the generalized code which actually mimic the exactly what we are doing on board. Okay, it is something like that in a digital circuit when we used to go for a Boolean expression simplification, then there is a K-map and there is a tabulation method. Okay, so tabulation method is considered to be algorithmic method. That is being defined as a Quine-McCleskey method. So that method, if you write down the code for that method, then definitely it would work. Okay, so that means for a higher number of variable it will work. But when I say a K-map method, then K-map method is difficult to write down the code. Okay, so that is always thing that which looks easy on paper. Sometimes it is difficult to write down a code for a computer. But if something looks easy on a computer, but if you do it on a paper, then obviously it would be difficult. So we will see two more methods, which is purely algorithm based. Okay, so that algorithmic method we need to understand. So for that, whatever the step that we will see, it is somewhat longer steps that we need to follow. Okay, but the good thing is that the steps are finitely defined. So whatever the complexity of your algorithm, okay, if you follow this finite number of steps, then always you will find out the iteration bound correctly. Over here, as I said that we are just relying on our observation and we may come up with the wrong observation where we may miss something. If particularly we miss a loop which is having a maximum loop bound, then ultimately you will end up with the wrong value of the iteration bound, because iteration bound is the maximum of loop bound. So there may be a case that whatever the loop that you have not observed and that is actually contributing towards the iteration bound, then you will come up with the wrong iteration bound. So that's why we want to see another method which is algorithmic based method, and that is LPM. So I will stick with this graph, okay, and then we will see with the LPM method. So there is one matrix is drawn, okay, so that matrix is required. So initially just I have drawn this particular matrix. So we will see LPM method. LPM stands for longest path. Now this method depends upon total number of delay element in DFG. So the complexity of this particular algorithm depends upon the total number of delay element for your graph. Now, as it depends upon total number of delay elements, so you need to first observe how many delay elements you have in your graph. So how many delay elements you have? Yes. How many delay element you have in particular graph?
Four.
Four delay element. Okay. Now, so you need to construct L raised to M, where M is 0, 1, or I think it is starting from 1. Sorry, it is starting from 1. So it is where M is 1, 2, 3 up to D. So you need to actually construct a matrix LM where M is 1, 2, 3 up to D. So here the total number of delay element are 4. So that means I need to construct L of 1, L of 2, L of 3 and L of 4. So I need to construct 4 matrices L1, L2, L3, L4. Now, when I consider a particular matrices L of M, then that L of M would be a square matrix and the size will be D cross D. First of all, I need to identify how many number of matrices I need to define for this particular graph. So that depends upon total number of delay element, and as well as the size of a particular matrix is also depend upon number of delay element. So that size or that matrix is always square matrix, and that is D cross D. So that means all these matrix would be of size of 4 cross 4 because D is 4. Here we are defining D is 4. So that means I need to construct L1, L2, L3, L4 and each matrix of 4 cross 4. Is it clear? So how I identify this? So that is from a total number of delay element. So delay element I have observed it is 4. So now good thing is it depends upon delay element, not depends upon your node. It may happen that your graph is having a 10 nodes, maybe 20 nodes. But if you have in a graph the delay element only 3 to 4, then the complexity is actually depending upon the delay element, not the number of nodes. Maybe you have 100 nodes, but for those particular nodes, the delay element may be 4 or 5. Okay, then the complexity is somewhat not difficult. That means the complexity is only of the order of 5, not of the order of 100, which is the number of nodes. Okay, now let's try to construct each matrix. Okay, so for a matrix, let's say I am defining L1. So for L1, there is L11, 1, L121, L131, L141, L211. It is a 4 cross 4. Okay. So L221. I am just defining the elements. L32 of 1, L33 of 1, L34 of 1, L41 of 1, L42 of 1, L43 of 1 and L44 of 1. So as this L1 is of 4 cross 4 size, I have defined each individual element of this particular matrix. Now please concentrate over here and if possible write down whatever I am explaining, because in a book you will find out directly this matrix. How it is being constructed probably means you will not able to get it by reading the book. Okay, so just try to concentrate at how this particular matrix is being constructed. Now for this particular matrix, total 16 elements. Okay, starting from L11 to L44. Now I need to find out each and individual element. So let's consider that I am interested in of Lij of M. So Lij says that I need to find out a path from Li to Lj where you have a D minus 1. 1 minute. Okay, sorry, M minus 1 delay element. So when I say M, so what is M over here for our first matrix? 1. So that means if I put M equal to 1, then 0 delay. So if I put m equal to 1 over here for this particular matrix, so that means I need to find out Lij of 1. So that means Li to Lj, zero delay element. Okay. So let's try to start with first. So let me just rub out this thing. So now let's say that I am interested in L11. So I is equal to 1. Here if I consider, then I is equal to 1, j is equal to 1. Just observe this equation. So I, because this is 1 1, so I is 1, j is 1. So that means I need to start from Li. So instead of Li, just treat this as a Di. It would be easier to understand. Okay. So it is Di to Dj. So I am just writing in terms of the delay element. Okay. So I is equal to 1 and j is equal to 1. Okay. So now I need to go from D1 to D1 where there is a zero delay element. Where is D1? D1 is this. So I need to start from D1. I need to reach again a D1 and I need to find out a path where I can start with D1, I can end with D1 and there is a zero delay. So if I start from here, then there is one path only where it comes D2. So that means whatever we says that zero delay element, that condition will not be satisfied because I need to start with D1. I need to again come back to D1. See, there is a various way to do it. I can start from this point. I can come back again to D1. But here you will observe D2. That means one delay element you will observe. Similarly, you will go like this. Then there is a 2 delay element. Then if you go like this, then there is a 3 delay element. So there are part is there. But what we want that where in between there has to be m minus 1. So for L1, when I talk about, then there has to be zero delay element. So that means I need to start with D1. I need to reach to D1 and I need to find out the path where there is a zero delay element. So over here, there is no such path exist. Okay. So when for Lij no path exists, then I will define that Lij value is a minus 1. When there is no path exists, then for that Lij I am defining minus 1. See, for a matrix I need to define some value. When I define 0, then it says that there is path exists, but the delay is 0. So that's why just to notate that there is no path exists and that I want to represent with some number. So that's why it is a minus 1 which is being written. Okay. So now for L1, I need to start with D1. I need to go for D1. And for that, I need to find out a delay where there is a in between zero delay element. Now let's do it for a second case. L121. So that means I need to start from D1. I need to reach to D2 with zero delay element. So that means I need to start with D1. I need to go to D1 and when there is zero delay element. Is there any path exist for this? Let me just
Yes, sir. Yes, sir.
1 minute. Maybe I think you can observe this. Okay. Just observe this. D1 to D2. There is this part is exist. So part is exist, but there is no in between node. So there is no delay which is being associated. Okay. So here I will write down L12 is 0. Why 0? Because there is no delay when I go from D1 to D2. Similarly, find out L13. So L13, that means I need to go from D1 to D3 with 0 delay. So I need to go to D, start from D1. I need to reach to D3. There is no delay. See, from D1 to D3, there is a one way I can reach it. But it will not satisfy the condition where with 0 delay. I can start from D1. I can reach to D3. Okay. So I can reach it, but with 0 delay it is not possible. So as there is no path exists, what I need to put? So first L11 I have observed, which is -1. L12 this is 0. L13 it is -1. Again find out L14. That means starting from D1, go to D4. In between there is 0 delay element. So there is no such path. There is a path. Okay, but there is no path where I can reach D1 to D4 without going through any delay element. So that is again -1. Why -1? It is no path exists. So similarly, observe it for remaining. Let's talk about L21.
Sir, please repeat L1.
Okay. Yes. Once again I should repeat. Okay. So let's try to do it again. So see, this is a matrix L1. For this matrix, I need to find out each and individual element value. L11, L12, L13, L14 up to L44. So this way I can find it out. So Lij, where I need to start from Di, I need to go to Dj with in between m-1 delay. Since I am talking about L1, so m is 1. So if I put m is 1, then it says that I need to go from Li to Lj where there is a 0 delay, because I am putting m equal to 1 from this, because this is for L1. When I talk about L2, then I will talk about here 1 delay. When I talk about L3, then I will talk about 2 delay. But since I am talking about L of 1, where m is equal to 1, here it should be 0 delay. And this is fixed for all the elements. Okay, now I and j, depending upon this particular element, that would change. Okay, so for first element, that means I am talking about first element. So L11, this one. So that means I need to start from D1 to go to D1, because I is equal to 1, j is equal to 1. So that means I need to start with D1. I need to go to D1 with 0 delay. So you need to observe that if there is no path exist, then you need to put -1. So that means if I start with D1, is there any path through which I can travel and I can again reach to D1 where there is no delay? So there is no path. Of course, there are several paths through which I can start from D1 and I can reach to D1. But there is no such path where there is a 0 delay element. So there is a one part where there is a 1 delay element. There is another part where there is a 2 delay element. There is a third part where there is a 3 delay element. But there is no such path where I can start with the D1, I can reach to the D1, but there is 0 delay element. So if there is no such path, I need to put it -1. So that's why this first value is being written as a -1. So I consider L11 1 as a minus 1. Now L12 for L12. So here I is equal to 1, j is equal to 2. That means I need to start with D1. I need to go to D2 where there is a delay, zero delay element. So if you observe that this is D1, this is D2. So there is this path which do exist, but there is no delay which is being associated because there is no functional unit. Because always the delay of a node, that is a node is a functional unit, that we need to consider. But here there is no in between node when I go from D1 to D2. So that's why there is a zero delay. Now L13. So I need to start with D1. I need to go to D3, but in between there has to be zero delay. So there is no such path. L14. I need to start with D1. I need to reach up to D4, but there is no in between delay element. But still there are no such path. So there is minus 1. So that's why minus 1, 0, minus 1 for all these four values. I hope this one is clear. Yes, MTech.
Yes, sir. Yes, sir.
Okay. Now similar way you need to find out for all remaining 12 because total 16. So L21. What L21 says that I need to start from D2. I need to reach to D1 with zero delay. So what will be the delay on this part? 211. I can start from this and I can reach to D1. So that means I am starting with D2. I am reaching with D1 and there is no in between delay. So that is 2 plus 1 plus 1. So that is 4. So that is being written over here. So this way I request you to find out all the remaining elements. And if you are getting any issue, let me know. Find out all the elements. The answer is already shown over here. So if you are not getting any element value as per this particular L1 graph, then let me know, I will explain. Otherwise, if you remember this formula, then you can do it. Yes, MTech, if you have any issue, let me know. I request also you to calculate this. As I said that in a book you will not find out this kind of explanation what I am doing. So I will give you 5 minutes to complete the remaining. I believe total you have 11 elements remaining.
L2 matrix, over there, if there is an element L13, so you have to go from 1 to 3 with one delay element.
So there is another method also to do it. Okay, so don't go for L1, means don't go for L2. You need to calculate L1 only. So that means you need to find out L2 to L4 4. Don't go for L2. That I will explain. Okay. So L2 onwards I will explain. But just try to complete for this L1 matrix only. So L22 should be -1 because there is no path where I can reach from D2 to D2. D23, that means L23, that is D2 to D3, that is path which is clear cut visible. This path D2 to D3 part is exist, but there is no delay element. That's why it is 0. See, this -1 doesn't suggest that this is a -1 delay. And obviously we have seen at the time of the retiming, there is no weight which is having a negative value. So नेगेटिव वैल्यू कभी आ ही नहीं सकती, डिले के लिए नेगेटिव वैल्यू हो ही नहीं सकती. Just to mention that there is no part exists, there is one notation we need to use, but we can't use 0 because 0 suggests that there is a part but delay is 0. But we need to actually identify, we need to mention that there is no part. So in order to mention the no part, we are using -1. Okay. ओके कंप्लीट हो गया.
Yes, sir. Yes, sir.
ओके
Yes, sir. Yes, sir.
ठीक है. जस्ट टू शो द रैंडमली L41 से क्या करना है, D4 से D1 तक जाना है. दैट मीन्स D4 से D1 तक जाना है, तो ये पार्ट आएगा. तो इस पार्ट में 2 1 1 1, सो दैट्स व्हाई इट इज 5. ठीक है. So this way the L1 matrix could be constructed. ठीक है. Okay. So our problem is not actually still half done. It is only done 20%. Because this is just for L1. We need to construct L2, L3, L4. So let's see now for L2. So I am just removing all these. Let's remove these also. So now we are interested for L2. So for L2 again, I have L112, L122 up to L442. So that means L132, L142 and L412 like this. Okay. Now I need to find out L2. Now in order to find out L2, what you need to do? Now for that, there is a one expression. Just let me write it down for that. Okay, so what this says that this is, just understand it is 1, correct? Okay, Lik maximum of K belongs to capital K minus 1 comma Lik 1 plus Lkj. This is Lkj M. Okay. Now, if I go back to my previous expression where it is being written that if I want to find out Lij, then I need to go from Li to Lj or Di to Dj with M minus 1 delay element. So that means now I need to travel from Di to Dj for L2, 1 delay element. When I talk about L3, then 2 delay element. L4, 3 delay element. So that means I need to observe in between delay element. Now in order to simplify this K is in between delay element. That's what I am talking about. K is that in between delay element. That means I need to find out any K through which I can reach from Di to Dj. Okay, because now I need to find out of one delay element. That means I will travel from Di to Dj, but there has to be one delay element. So that Dk I need to find out. So that K notation is over here. Okay, maybe for a L2 it is simple, but then if you go for a L3, L4, then that number of delay element going to be increased. Then do delay element, teen delay element that you need to observe. And if you need to observe only, then again you come back to that same method, that loop bound. Okay, so just to do it in a mathematical way for a algorithmic representation, this is an expression where this K is any in between value which you need to look for to reach. Okay, so now let's consider L21. L21. Okay, sorry. Here slightly mistake. Here it should be J. Here it is J. Okay. K should be over here. Okay. So Li to J, in between K is there. So L21. So that means I is 2, J is 1. So let's start with L11 only. I am just let's put it 1 only. Okay. So 1 1, where I am considering I is equal to also 1 and J is equal to also 1. So L11, okay, and that is L111 of this is, I am talking about 2. So for that I need to find out in between K. K should be what? K should be any delay element. Okay. So now in order to do that, let's try to build up the concept that K could be anything. K could be 1, 2, 3, 4. So K could be 1, 2, 3, 4. So here what is the possible K? it could be 1, 2, 3, 4. Okay, so let's put it all of those and try to solve this. So 1, 1. So if I put I and j is fixed, the k is varying from 1, 2, 3, 4. So that means I put 1, 1, 1 plus 1. This is actually m plus 1. Okay. So this
Excuse me,
here
sir.
m is- Yes.
सर एक बार वापस बता दो k क्या है?
Okay. K जो है, see, if you just go back to our previous discussion where we talk about Lij. So what it was says that di to dj with, if I am talking about m, then with m minus 1 delay. Okay. So now if I put m is equal to 2 over here, because here we are talking about L of 2. So that means L I J J 2. So that means I need to go from D1 or say Di to Dj where I have a 1 delay element, because I am putting m is equal to 2 over here. So that means I need to find out any in between delay through which I can reach now. Previously, I need to think about there is no in between delay element when I travel from Di to Dj. But now I need to find out any in between delay element. So if I look at this particular graph, then you have a total 4 delay element. That means your k, which I consider as any in between delay element, this could be D1, D2, D3, D4. Yes.
Yes, sir. Yes, sir.
Okay. So I am just putting all these possibilities. Okay. So I am putting k equal to 1. See, L11, I is fixed, 1, j is fixed because this is 1, this is 1. Now for k, I am putting 1, 2, 3, 4. So this is my k. So this k and this k. So this is 1, 1, 1. Then what is the second? L1, 2, 1 plus L2, 1, 1. L1, 3, 1 plus L3, 1, 1. L1, 4, 1 plus L4, 1. See what I have done for this k, just try to observe. This k, I have put all the possible value. I and j is fixed when I talk about L11. But I have put this k value 1. This is for k equal to 1. This is for k equal to 2. This is for k equal to 3. And this is for k equal to 2. Okay. Now try to put those value over here. So that means if I want to find out L112, then it is maximum of minus 1, L11 of 1. L11 of 1, what is that value? Minus 1. It is minus 1, that means there is no part exists. तो ये ऑटोमेटिकली निकल जाएगा. अगर ये पार्ट ही एग्जिस्ट नहीं है तो इसमें ऐड करके there is no way we can do it. Okay, so this there is no part, so L11 तो है ही नहीं, L12 that do exist. Okay, so here it is 4 and L21, sorry, L12 was 0. Just observe our previous graphs. L12 was 0. And what about L21? L21 was 4. L13 not exist. So that means this will be cancelled out. L14 again not exist. So that is maximum of minus 1 and 4. So that is the value is, so L22, the first value which I will get it. So let's write down now L2. So L22 इसकी जो फर्स्ट वैल्यू आएगी वो मेरी 4 होगी. Now again I need to find out same, but now the J is 2 because I am talking about now L12. L12 है तो मेरी J वैल्यू अभी 2 हो गई. J value 2 हो गई, so that means every time when J is there, J is using, I am over here. That means here there will be a change where I need to write it down. Where I need to write it down 2. Here again I need to write it down 2. Here again I need to write it down 2. Here I am again writing down 2. K तो K चारों पॉसिबिलिटी मैंने कंसीडर कर दी. नाउ दिस इज L11 प्लस L12 ऑफ 1. L11 फिर से एग्जिस्ट नहीं है, L13 एग्जिस्ट नहीं है, L14 एग्जिस्ट नहीं है. तो फिर ये जो L12, L32, L42 उसका कोई मीनिंग ही नहीं है. आपके लिए तो सिर्फ यही इंपॉर्टेंट है कि ये L12 जो पहले 0 था, नाउ प्लस L22. L22 क्या है? This L22 of 1 क्या है? -1. तो that means कि ये L12 जो है उसके लिए मेरी -1 वैल्यू आएगी क्योंकि सारे नॉट एग्जिस्टेड पार्ट है. So that means there is no way through which I can travel from D1, I can reach to D2, but there is in between one delay element. Now similarly put L13 value. So J is equal to 3 now. And try to solve this. I hope you are following. This equation you need to just write it down. And once you try to do it, then you will get the confidence because ultimately you need to just observe that if there is a -1, then that term you need to just cancel out. And that term will be cancelled out for every time. See, here this is not at all possible. So that's why this over here, this 3 term gets cancelled. Only you need to concentrate over here because that is the only exist part. And with that you will observe that you will get the first time 4, but second time this part is exist, but this L22 1 was not exist. So that's why there is not at all exist part. Now you need to find out L13. L13, just apply this equation and try to find it out. Okay. If anyone will come out with the L13, let me know. Yes? Very good. It is 0.
Directly.
So next value will be 0. Very good. Now L14. Yes, MTech. Any one of you need to give the answer. L14 for this L2 matrix. What should be the element over here? So here you need to put I equal to 1, J is equal to 4 and then solve this. So ultimately 4 will be over here. 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 So here it will be L14, 214, 3444, and every time it is 1. Huh? Okay. Please go ahead and find out all the value. Yes, MTech, I am expecting from you. What would be the L142? Yes, you are correct. But I am asking now from MTech. So you just go ahead. You are correct.
-1.
-1. Very good. -1. Now find out all remaining 12 value with the same concept. Okay, as I already informed that it looks tedious, but we are actually solving what should be solved by a computer on paper by us. So that's why it is a longer process. Okay, this supposed to be right computer, in a computer you need to supposed to write down this equation only. But now you are trying to solve on paper by using this equation. What has to be? Simply one line in your computer. But here we need to understand it, how it could be calculated on paper. So that's why it looks somewhat tedious. Okay, I am interested in L21. L21 में अभी I भी 2 आ जाएगा और J इज इक्वल टू 1 आ जाएगा, तो उसके हिसाब से आपका ये एक्सप्रेशन चेंज होगा. आई बिलीव दैट यू कैन डू इट. L21. So that is maximum of -1. I is 2. J is 1. So put those value L21 1 plus L2, sorry, L1
Five, sir.
5, sir. Very good. It should be 5, but I am explaining how you are getting. So L2 2 of 1 plus L2 1 of 1. L2 of 3 1 plus L3 of 1 1. L2 4 of 1 plus L4 of 1 1. Again here the K is 1 consider, K is 2 consider, K is 3 consider, K is 4 consider. And this I is equal to 2 and J. This is all about I. This is J. Okay. Now maximum of -1 L21. L21 is 4. L11 no part exists. This get cancelled. So this is not required now. L22 of 1. L22 of 1 is -1. This gets cancelled. L23 0. So here it is 0 plus L31. L31 is 5. L24 not existed. So that means here only I need to consider two values, L21 and L this one, 23. Apart from that, these two are not existed. But with this, whatever the second part which is being created, that is not existed. So only this option is remaining. So where L31 and L23 plus 31. So the L23 was 0. This one is 0 and L31 is 5. So this is 5. So answer is 5. So next element is 5. Now I request you to complete this remaining part. So still you have to find out the total 11 element. L22 if somebody has found, then let me know. Okay, it's 4. Very good. So let me just write it down, the remaining element. This is 4. This is -1. This is 0. This is 5. This is 5. -1, -1. -1, 5, -1, -1. So this is my L2 matrix. If you are not getting any of this element value, let me know. I request to try it out. अभी आपको फिर L3 करना है, L4 करना है. Equation same रहेगा. The only thing is you need to remember that this is M plus 1 and this is M. Here it will be always L of 1, but this is LM. So for L of 3, this will be 2. So L22, hope you are getting 4. If you are not getting, let me know, I can explain. Or any of this element, if you are not able to get it, let me know, I can explain. So just try to complete it. And if you are completed, then try to go for L3. Probably for L3, I will just explain it for 1 or 2 element. But if you want to try it out, then go for L3.
Sir, sir,
हाँ हाँ बताओ.
sir, L2 3 value. I'm getting different.
L23. Okay. Let me calculate. So just I am deleting this. So you are interested in L232. Okay. So I is equal to 2.
Sir,
J
sorry,
is
sir. Sir, I have done it for L231, sir.
L231. L231 was the
Acha,
previous.
sir.
L232 now you need to talk about. Okay. So let me do it. Okay. -1 L2. Since I is 2, I am putting K different value. 1 plus L1 3 1. L2 2 1 plus L2 3 1. L3 2 1 plus मैंने ये गलत लिख दिया. L231 plus L331. L241 plus L431. Okay. So L21, this is 4. This is 4. L13 not existed. This gets cancelled. L22. L22 again it is not existed. L23. L23 is 0. So I can write it down 0 over here. L33 not existed. L24. L24 is not existed. So none of the part is existed. So that's why it is -1. Yes. None of the parties exist. That's why it is -1. So maximum of -1 and then whatever the equation, but all the part giving non-existence. So that's why it is a -1. Okay. So I believe that you are able to get it L2.
एक्सक्यूज
Now-
मी सर
Yes.
सर L2310 कैसे आया?
L231. Okay, you are talking about this element. Okay ना?
नो सर अभी जो आपने सॉल्व किया था ना, हाँ वही
नहीं. L231 you that means for the previous matrix, that matrix, this matrix you are talking about.
यस सर.
तो उसके लिए कैसे करना है? उसके लिए तो मुझे L23 that means D2 से चालू करना है, D3 पे जाना है. इन बिटवीन 0 डिले एलिमेंट चाहिए. तो आप D2 से स्टार्ट कर रहे हो, यहां से D3 पे जा रहे हो, ये पार्ट एग्जिस्ट है और देयर इज 0 डिले एलिमेंट. देयर इज पार्ट एग्जिस्ट but there is no in between delay, so that's why I have written 0 over here. Yes, is it clear?
यस यस ओके सर.
Okay, ठीक है. So with this L2 matrix you can complete. I believe that you can complete now. Now just focus on L3. L3. So for L3 again I will use this formula only. So L first element is L11. L11 of 3 that is maximum of -1 L11 of 1 plus L11 of 2. Here it is M. So this is M plus 1, that is 3. So M has to be 2. So again, it will do like this: L121 plus L21 of 2. L13 of 1 plus L31 of 2. L141 plus L41 of 2. This is the formula. Now L11, ये पार्ट आपका नहीं एग्जिस्ट है तो भूल जाओ. L13 भी एग्जिस्ट नहीं है, देखो नहीं, हाँ L13 भी एग्जिस्ट नहीं है, L14 भी एग्जिस्ट नहीं है, L12 ही एग्जिस्ट. So L12 is 4. L21 of 2. 21 of 2 क्या है? L12 is 0. हाँ sorry, this is my mistake. This is 0. L12 is 0. L21
5.
L21 of 2. That means I need to talk about this. 5. So it is 5. So that means L11 has to be 5 over here. Yes? ठीक है? Similarly, find out L2. So L2 के लिए मेरा J2 हो जाएगा. J2 हो जाएगा. So the change that would be there is 2 over here. 2 over here. टू होने से भी ये जो मेरा फर्स्ट पार्ट है वो तो वही रहेगा. 0 1 2, सॉरी ये 1 2 और L22 क्या है? L22 of 2 4. So it is 0 plus 4. So this value has to be 4 now. Okay. So remaining element, find it out. 1 0 8 9 9 5 5 minus 1 4 5 5 minus 1 minus 1 minus 1. ठीक है. अभी L3 हुआ है, L4 अभी भी बाकी है. Okay, so L of 4, calculate it. So now I request to complete this example. L3 और L4 आपको खुद solve करना है. And if you are not able to get it, let me know. I will solve it for you. ठीक है. ये 4 खत्म होने के बाद this you can consider is just a prerequisite what we actually require to find out the iteration bound. So iteration bound तो फिर इसके बाद कैलकुलेट करेंगे. L1 3 of 3 हाँ -1. Thank you. This is -1. ठीक है. So L4 भी मैं लिख देता हूं. ओके, जस्ट टू L4 की वैल्यू मेरे पास हाँ है 8 8, 5, 4, -1, 9, 8, 5, 4, 10, 9, 5, 5, 10, 9, -1, 5. Okay. Let me complete this example. I think still we have a few minutes to. Okay. Now iteration bound. Once you construct L1, L2, L3, L4, all metrics, then the final answer of iteration bound. Iteration bound is defined by T infinity. This is iteration bound. Okay. So iteration bound equation is maximum of IM belongs to 1 to D L I of M by M. So T infinity is maximum of IM, which belongs to 1, 2 up to D Lii of M divided by M. Okay. I. So that suggests that diagonal element I need to find it out. Diagonal element I need to find it out. So for all these M, see this is I and M that belongs to D. So that means I need to take care for all M, and for all M I need to talk about Lii element. So आपका L1 से स्टार्ट करना है डायगोनल एलिमेंट. सो L1 से स्टार्ट करूंगा तो डायगोनल एलिमेंट कौन कौन से है? ये चारों. ठीक है, पर ये तो -1 है. -1 है वो क्या बताता है? पार्ट एग्जिस्ट ही नहीं कर रहा. दैट मीन्स वी डू नॉट हैव टू थिंक अबाउट इट. ये डायगोनल एलिमेंट, ये चार है, ये -1 है. सो दैट मीन्स 4 by M. M is 2. So 4 by 2, 4 by 2. That is for this 4. So first one is for this one, second one is for this one. Again, so 5 by 3, 5 by 3, 5 by 3. This we need to ignore it because it is a not exist part. Then this one. So it is 8 by 4, 8 by 4, 5 by 3, sorry 5 by 4, 5 by 4. So that means maximum of 2, 2, 5 by 3, 5 by 3, 5 by 3, 2, 2, 5 by 4, 5 by 4. So what is the maximum value? 2. और शायद हमने आज लूप बाउंड मेथड से भी कैलकुलेट किया था. व्हाट वाज द आंसर? दोनों से आंसर सेम ही आ रहा है. एक 10 मिनट में हो रहा है, एक 1 घंटे में हो रहा है. ओके, बट whatever we have solved it by spending 1 hour time, that is a systematic method where we are actually writing a program. So ये जो इक्वेशन है और उससे पहले ये वाला इक्वेशन है, ये वाला एक्सप्रेशन है, और उससे पहले वाला जो है Lij di to dj to m minus 1, these three only you need to write it down. Then just input this graph to your computer. You will get the answer by these three equations only. But whatever we solved it in 10 minutes for a loop bound, you require a close observation. वो computerized method नहीं है, वो algorithmic steps की method नहीं है. That you need to find it out. So that method fails when you have a larger number of nodes. क्योंकि आपका नोड जितने ज्यादा होंगे उतने आपके कनेक्शन ज्यादा होंगे. So over there the loop that you need to identify, that becomes difficult. But यहां पे नोड पे डिपेंडेंट ही नहीं है. किस पे डिपेंडेंट है? डिले एलिमेंट पे. तो हो सकता है कि आपके उसमें ग्राफ में 100 नोड हो, लेकिन डिले एलिमेंट अगर 5 है या 10 है, then also somewhat easier. Of course अगर 10 डिले एलिमेंट है तो L1 to L10 10 क्रॉस 10 के मैट्रिक्स फाइंड आउट करने हैं. हर एक मैट्रिक्स में 100 एलिमेंट होंगे, तो टोटल एलिमेंट आपके 1000 होंगे. ठीक है. So that is somewhat I can also understand is a difficult. Okay. So whenever if anything related to this, if it is being asked in an exam, so first thing is you need to ensure that you first identify what is the number of delay element. Okay, and what I believe that at that time the examiner will also take care of that this should be solved within some finite time. Okay, so of course I can see that this problem require at least 20 minutes. Once you solve more and more problem of such kind and you will get somewhat confidence, then it requires at least 20 minutes. And that also depend upon your number of delay elements. I am talking about this problem that you can solve it. If you want to do it, then in 20 minutes you can do it. There is no problem. Okay. So next time when we will meet, we will talk about another algorithmic method which is MCM, minimum cycle mean. So that we will discuss. Okay. Yes. Any doubt? Okay. MTech, any doubt?
No,
So
sir.
I just leave up to you that you complete this L1, L2, L3, and once you complete this, then you will get final answer like this by this equation. So just ensure that all matrices and elements you found, and if you are not able to do it right now, do it later on and let me know tomorrow if you are getting any problem for any element. I will explain. Okay. ठीक है. So with that I am just ending up over my session. Thank you all of you. See you tomorrow. Tomorrow also we have a class 10 to 11 if I am not wrong.